Those of you who watch Chalk Talk regularly will know that this is the part where I give a funny introduction on the chalkboard. I draw funny pictures and make some sort of joke or analogy that relates to the technology we'll be discussing. Today, though, we're going to be talking about industrial Ethernet, which is unfortunately, totally not funny. Listen to what they're giving me here. Industrial Ethernet walks into a bar looking for a hookup. No. Okay, how about this one? How many industrial Ethernets does it take to... Nope, not doing that one either. Ethernets? Is that even a word? Come on, guys. All right. How about industrial Ethernet, a priest, and a rabbi? Are you kidding me? No, we are not doing this. Look, if you've got any awesome industrial Ethernet jokes, feel free to drop them in the comment box below the player. But for now, I'm moving on. Hi, I'm Amelia Dalton, host of Chalk Talk, and we're going to talk about industrial Ethernet today. Don't worry, it won't be boring. Even though industrial Ethernet doesn't make good joke material, it's an interesting and challenging problem that we can solve together. My guest today is Suhel Dhanani from Altera, and we'll be discussing, guess what? Yep, simplifying industrial Ethernet design. And don't forget to click that Download Now button below your player. There you can download a free white paper entitled Support All Industrial Ethernet Standards on your next drive design. Thank you so much for joining me today.
Thank you for having me.
So we hear a lot about industrial Ethernet these days. Tell me about the trends in industrial Ethernet.
So by now, it is pretty well understood that industrial Ethernet is becoming the dominant technology within factory automation systems. And this has been documented in countless articles and market research reports. What I believe does not get quite the same level of attention is the implementation of this technology in the vendor systems.
Okay.
So we see essentially two key trends playing out in the market. The first trend is the proliferation of these standards. Just like the field bus protocols preceding them, there are many variants of industrial Ethernet protocols. And most importantly, the market is not coalescing around any one dominant standard. Drive system vendors must be able to support about 6 to 8 standards in order to sell their products worldwide in different factory plants.
Wow, okay.
So the second trend we also see is that these communication functions are getting deeply embedded inside of a device. And that what is driving this really is system cost, form factor, power budgets, because they're all shrinking. So in the past, we saw customers buy an off-the-shelf communication module costing a few $100s to implement the industrial Ethernet function. But this is no longer cost effective. So what we are saying is people are embedding the industrial Ethernet functions inside of the single piece of silicon to achieve the holy grail, which is the drive on a chip. And they're increasingly doing this within FPGAs.
So I'm starting my design and I know it's going to have industrial Ethernet. And I don't know where to start. What are some of the challenges I'm going to run into?
There are a lot of challenges that you would run into once you start building a factory automation system with industrial Ethernet functionality. The main thing is that you will have to design your system so that it can work with any PLC.
Okay.
And for this, you will need access to multiple hardware-tested IP protocols. Or of course, you can develop all of them yourself from scratch.
Sure.
But of course, time to market and budgets are getting compressed for you, I'm guessing, like everybody else. And it's really not practical to go and negotiate separately with different protocol vendors and license each and every protocol separately.
Right.
Also, I'm sure that as systems vendor, you have different systems with different feature sets, and you want to be able to scale the hardware depending on what features you're supporting. So you need to make sure that whatever IP that you license, it works across the range of FPGA densities.
Okay, that seems like a lot to handle. Suhel, help me out with this. What's the next step?
So what I'm going to do, Amelia, is help you simplify your industrial Ethernet design.
Great.
We are going to give you industrial Ethernet solutions available for all of Altera's FPGAs with easy access and readily available. So you pay no license fees. You don't have to do any new license negotiations. You do not have to track your per unit royalty, and you get all the protocols that I have listed here.
Great. Okay, so you're going to solve my industrial Ethernet design problems, walk my dog, and cook me dinner. How the heck are you going to do all of this?
So what we have done is we have partnered with Softing. Softing is a world leader in industrial Ethernet intellectual property protocols. That's what they specialize in.
Okay.
And with them, we have come to a joint agreement which provides our customers, you, with a simple out-of-the-box solution. To get started, you would just download whichever industrial Ethernet protocol that you wanted. And this includes the software stack, by the way, straight from Softing. All of these IPs work with all Altera Cyclone devices. You would then purchase a security CPLD from Altera, which has the license, and it will enable all the protocols shown here. You use the same security CPLD for any one of the listed protocols. However, only one protocol is enabled at a given time.
Okay.
As I mentioned earlier, there are no license fees or separate per unit royalty tracking. Altera has taken care of all of this. All you need to do is buy the devices, the FPGA, and the security CPLD from Altera's worldwide sales network.
Okay, so let's dive down a little bit and get into this IP from Softing.
That's a good question. So let's look at the Softing's protocol IP. What does it have?
Sure.
It has a logic component, if you will, and a software component. The logic or the hardware component implements two Macs and a switch. This is a black box implementation. It is shipped as a top-level component in a QSYS system integration tool. The software component is a binary file, and this implements the protocol stack.
Okay.
The binary file is run on a Neos 2 processor. So while we ship the black box and the library file, you will need to create what is shown here as a gray box. And the gray box is a Neos 2 connected in a very specific way to the black box IP. The gray box must be configured precisely as shown in the documentation, and we'll even throw in a reference design that shows you how to connect it all up.
Nice.
You can hook up the rest of the design to this black box and access the protocol stack via a defined software API that is common to all the protocols. So when you swap out one protocol for the other, you do not have to change the rest of your design.
Great.
It all works.
Okay, Suhel, what's available right now?
The first industrial Ethernet cores that are available are the Profinet RT and the Profinet IRT.
Okay.
They are available now. You can download them from Softing's website. They are implemented as a switch IP core with two external ports for the industrial Ethernet PHYs and one internal port for the embedded processor, in this case Neos 2. The expected device utilization is shown here, and it is so small that it can be implemented within a small Cyclone 4 device.
Okay, I think I'm ready to get started. What do I need to do first?
Well, there are three simple steps for you to implement an industrial Ethernet design in Altera FPGAs.
Okay.
First, go to Softing's website and download the slave protocol IP. This supports all of Altera Cyclone devices. Evaluate this IP using the Altera Quartus software tool and the associated development kit. Then you can purchase a security CPLD from Altera and use this to enable any one of the listed protocols. Remember, there are no license fees or separate royalty per unit that you need to track or pay to any third party. Again, all you need to buy are devices, the FPGA and the security CPLD. And by the way, the security CPLD is priced at about $3 in 5,000 unit volume.
Very nice.
So let me give you a little bit more detail. To get the protocol IP for evaluation in software and hardware is as simple as 3 clicks. Go to Altera's website, altera.com/industrial Ethernet. Here you can read more information on our protocol offerings. When you're ready to start evaluating your industrial Ethernet protocol, click to a special area on Softing's website. Enter your requested information and click again, and you'll be presented with a standard IP license agreement. Once you accept the license, you can then click the download button and you can get to a zip file that contains everything you need to get started.
Very nice. Okay, once I've downloaded that zip file, what am I going to find in there?
The zip file has both the FPGA IP, remember that is the Mac and the switch that I talked about before? And that's available as a QSYS black box, as well as the protocol stack in a binary format.
Okay.
This protocol stack is designed to run on an ECOS operating system, which runs on, of course, in Neos too. And by the way, we include this operating system within the binary file as well.
Very nice.
With these two components, now you are ready to put together the gray box, as we talked about before.
Uh-huh.
We will also include two reference designs so that we have built the gray box for you. One of the designs has a SDRAM controller, and the other one has a DDR memory controller, depending on which memory you may choose.
Okay.
The reference design shows you how to interface your custom logic to this protocol IP. We will also give you a sample application code so that it gives you an example of how you can interface your application, which is running on maybe a separate Neos, with the protocol stack.
Okay.
And of course, we'll include all the documentation, the data book, the handbook, and the FAQs inside the zip file. So bottom line is you get everything you need to get started with your design right away.
Great. Okay, so that's great for IP. I'm going to need some hardware at some point too, right? Are there boards and kits that are appropriate for this type of design?
Absolutely. So we have made sure that the protocol IPs are tested and designed to work on the Cyclone 3 and the Cyclone 4 FPGA families. And these protocol IPs can be validated in hardware by using either the Cyclone 4 base industrial networking kit available from Altera,
Okay.
or the Cyclone 3 base real-time Ethernet module, also called the RTEM, from Softing. Both of these development platforms have been in production for a while now, and all the industrial Ethernet protocol IPs that have been developed have been validated in hardware using the same development kits.
Very nice. So what about when I'm done with my design and we're ready to go to production?
When you're ready to go to production, the way forward is easy. You do not have to enter any complex license negotiations. Just go to Softing or Altera's website and get a production license. You don't even have to talk to anybody.
Wow, okay.
If you want to get a production license for more than one IP, just indicate that on the website. We understand that you may need to support multiple protocols, so that is completely okay. And you will get a license with the appropriate feature lines. The license allows the protocol IPs to work in full production mode as long as the security CPLD is connected.
Ah, okay.
So remember, you will need to purchase a security CPLD from Altera to enable these protocols.
Okay, so when are the various protocols going to become available?
Well, we started with Profinet. So we started with the Profinet RT and the IRT protocols, which are available now. Next, we'll have the Ethernet Power Link protocol, which will be available in early 2013. And following that, we're looking at Modbus as well as Ethernet IP, and then finally Profibus. As we add these protocols, we do seek your feedback in order to better prioritize the availability of the protocols within the same license framework.
Okay, Suhel, this has been a lot to cover. Recap the main points for us, if you don't mind.
Absolutely. So we are recognizing the fact that industrial Ethernet implementation increasingly makes sense in a programmable device. To enable this, we have partnered with Softing to bring you a simple, no-hassle way to get most of the top industrial Ethernet protocols. This methodology gives you access to a hardware-tested protocol within 3 clicks on the web. No large upfront licensing, no tracking per unit royalty. Using a small, low-cost security CPLD from Altera satisfies your license agreement, and the royalty is taken care of by Altera. If you wish to learn more about this innovative licensing structure, please visit us at altera.com or click on the links below.
Fantastic. Well, I think that's all I have time for today. Thank you so much for joining me today.
Thank you.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.